Someone help me on 6. A 3p what, Drea? And what are you left with? I'm sorry, I can't hear because people are being rude, but it's okay. I mean, it's live, but wait, go ahead, Travis. Okay, Drea and Travis get a point. 7 is grouping, she says. So tell me what you want to do, Abby Grace. And I wrote it up instead of down because I have a different suggestion. Abby Grace is right and she gets a point. Why did Abby Grace make life too hard though? There's no GCF. Yes, Travis get a point. Combine those like terms. 4x and 2x add to 6x. I don't necessarily, I understand that when I see 4 terms, I think grouping. I get it. But hey, on this one, actually, like terms combined. 4 plus 2 is 6. 4 times 2 is 8. Hey, I could have gotten the right answer anyway and not had to group, especially those of us who still are stinking it up at grouping. There is no need to even group today. Number 5 is the one you should have been working on, so because I was going to give your group 3 points if you got it correct, but I'm assuming you haven't done it or you said it wasn't possible. Would someone like to surprise me? Yes, ma'am. Okay, so you said the 4 here and the 7 here. I'll come back to that in a second. So let's see. I know it had to be 7a and a in order to get 7a squared. I knew it had to be all plus signs because the entire thing was positive. The question mark was what went at the end. So we had options of what multiplied to 28. So it was either 1 and 28, 2 and 14, or 4 and 7. And then we have to decide what order we did it in because we could have done 1 and 28 or 28 and 1. Had a lot of options. She says it's a 4 and a 7. If she's correct, she's getting her group 3 points. 7a squared plus 49a plus 4a plus 28. 49 and 4 do add to 53. She gets her group 3 points. Thank you, Drea. Okay, you had your packet out yesterday. I want to go back to your packet, your notes. Someone in the room just left their whole packet in the back. Like, oh, I don't need that. Okay. That's nice. I don't know how you're going to do math in math class, but okay. Especially since the latest homework assignment is from the packet, but okay. Okay, so since we're wanting to find the sum, the difference, the product, and the quotient, yes, it would be in the 212. No, yeah, 2 days ago is 212. That's correct. That feels right. Okay, I can find the sum, the difference, the product, and the quotient. Okay. We did problems involving that, so basically we started a new chapter, but the new chapter so far has been pretty easy. All that's changed is the notation, because we're not used to seeing an f plus g of x, but it literally means add the f to the g. That part you can do. Or f minus g means f minus g, but again, it's still all math you can do. The only thing you're not used to is this function notation. So that's really the change we're adjusting to, this notation. So that's what we did Tuesday. That was yesterday. And then we also talked about with multiplication, life was still good. And division was even nicer. You don't have to do synthetic. You don't have to do long. You literally just have to put f over g. Hopefully, the numerator can factor in. You could cancel with the denominator, but sad day, it didn't happen in our notes and didn't happen on our checkpoint. You're hoping it can, but it's not going to work out. regardless, there is a number, I'm calling it a no-no number, which is silly, but anyway, there is a number we can't use because in math class you can never have the denominator equal to 0. So since this bottom can never be 0, if you'll set it equal to 0, you'll figure out what that number is we can't use. So I did x plus 4 equal to 0. I solved x cannot be negative 4 because if I plug in negative 4 right now, I'd have a 0 in the denominator and that's not allowed. In fact, yesterday we even graphed it to see that yes, our graph even skips over negative 4. So if you're in your checkpoint did, if someone asks you for a restricted domain, they're just meaning, are there any numbers we should be concerned about because of this denominator? If there is no denominator, or there is no number we can find, then there is no issue, there is no restriction. Okay, and then a few pages away from that, not the next page, the page after that, it says 6-1 steady added intervention. At the very bottom of it, there are 5 problems. And we discussed that they're due tomorrow, and you had some time yesterday in class to do those and a checkpoint. We discussed they're due tomorrow, and even though there are only 5 problems, they're actually worth 20 points. Why are they worth so many points?
You want to do 4 things on each problem.
Okay, I heard it from 2 and 5, and they can both get a point. So that's why it's worth so many points. It's due tomorrow. So when I stop rambling today, if you're unsure of what you should be doing, that would definitely be one of the things. Okay, yesterday we also took a checkpoint on this. I have about 4 people who didn't finish their checkpoint. So it's not a big, I mean, you haven't got to 0 yet because I'm not quite as on my game as I want to be. But I'm going to have the 0 in later today, so you want to make sure you give me your checkpoint and we'll go over it and all that jazz. Okay. We do have new notes today, so back up a couple pages. I want to go to the page that says, it's one page back, composition of functions. It looks like this. We're learning one new thing today, and while it is new to you, if you pay attention, it's really not that big of a deal. And it comes up a lot on ACT kind of questions, so it's something you need to know. And it's something that's going to keep coming up in your pre-cal analytical math, your later math classes. Besides discrete, because we don't talk that much about functions because discrete is useless. Okay, so we are going to talk about function composition today. And sadly, there's something very important and tiny that we need to notice. What is the difference between those two things that I just wrote? Yeah, one's shaded in and one's open, so you get a point. Isn't that sad that there's that tiny of a difference and they both mean 2 different things? It's how sad that is. You think they've made a mistake and they haven't. It means something different when it's not colored in. What does it mean when it is colored in? It's multiplying, so I get a point. If we see that, they're telling us to multiply f and g. If we see this, they don't want us to multiply. They want us to do something called function composition. Okay, when I hear the word composition, I automatically think music and composing. So like putting some songs together or putting different parts, like the trombone with the clarinet and all that, mixing all the parts together. And that's what we're going to do with function composition. We're going to mix f and g together. Okay, so function composition, because math teachers are lazy, tends to be 2 different kind of problems. And literally it's because math teachers are lazy. Easiest question of the day. Why do math teachers use letter F most of the time? F for function, so you get a point. F for function. We're literally that lazy. F for function. And then so you know the second most used letter when it comes to functions is G, because it comes after F. And then the third most used is H, because we just go straight in order because we're lazy. So since we use F and G the most, we tend to call them, so we see a lot of this and a whole lot of this. We tend to call them FOG and GOF problems. So GOF without the L. Now, do you have to use F and G? No. Look at number 1 below. They use G and H. So it's not necessarily always a fog or golf problem. In fact, again, the important thing of the day is that open circle symbol. That non-filled in circle. That's the important thing. That's how we know it's composition. But it does happen a whole lot. So we tend to call them fog and golf. I'm going to save these bottom 3 for tomorrow. They're actually a little easier, but I don't understand. I don't see how we can do the next bottom 3 that are easier until we understand what on God's green earth fog and golf are. So let's go to the back and discuss fog and golf. Okay, so you know you love math class because stuff like this happens. What's 1 plus 5? What's 5 plus 1? Why does that work out? Yeah, and it's called the commutative property. So 2 times 3 is 6. Isn't 3 times 2 also 6? And isn't that awesome how that property works for most things? Too bad it doesn't work for fog and golf. The answer we get with fog is not necessarily the answer we're going to get with golf. In fact, today we're not going to have any of the same answers. So yeah, in regular math, when we use normal real numbers, we have this property, but sadly it doesn't work with fog and golf. So if you think you made a mistake because your fog and golf don't match, that's not necessarily true, unless they put a certain word in there, which we'll get to tomorrow. Okay, so we're going to go through and do all the fogs, and then we'll go back through and do all the golfs. And you're like, okay, how do we do a fog? I don't even know why they started writing it like that. They should have just always left it in this notation. Because I could kind of guess what this means. I had no idea what that meant. But these two things are supposed to mean the same thing. Now let's talk about things you've seen before. And we've spent a lot of time on this first semester, and you have all shown me you know how to do this. You even had a little bit of this with synthetic division on the last test. So if your problem, if we're looking at number 1, if it said F at 3, what would you tell me to do? If this is what we saw. How do you plug it in? So everywhere you saw an X, you would put a... So it used to be negative 3 times x, and now it's negative 3 times 3, and you got negative 9. We all have done that. It used to be negative 3x. They told me instead of x, plug in a 3. So everywhere I used to see an x, I put in a 3. That exact same logic is what's happening today. So we have f, it's negative 3, and then there's x. Negative 3 times something, but they don't want x. They tell us what they want. They want us to use g of x. So everywhere we used to see an x, we're going to plug in g of x, and g of x happens to be 5x minus 6. So it used to be negative 3x. Now it's negative 3, 5x minus 6. So again, we're using f. But everywhere in f we see an x, we're plugging in what g is. So it used to be negative 3x, and now it's negative 3. And everywhere we saw an x, we're putting in 5x minus 6. Yes, dear?
Will there be instances, like, maybe not that will there be instances where there are a lot of letters past just G and F, and you just have this long train of plugging things in?
Normally not more than 5 or so, max. But like in high school, no more than 3. Okay, if I distribute, I mean, there's still a little more math to be done. I get negative 15x plus 18. And then we're done. So the fog answer is negative 15x plus 18. And so the notation looked weird, but now that we think about it, I understand. Everywhere in F, I see an x, I plug in what I have for G. And if that didn't make sense, I swear by the 3rd time we fog it, it should click. So let's go ahead and go to number 2 and try fog with it. So number 2, I wanted to find f composed with g of x. Well, f was x plus 4. It used to be x plus 4. But now, instead of x plus 4, everywhere I see an x, I'm supposed to plug in g. Well, g is x squared plus 3x minus 10. So literally the guy on the inside is who we're plugging into the outside guy. Okay, so if I combine my like terms, x squared plus 3x, negative 10 plus 4 is negative 6. So the math part's not hard, it's just remembering who goes in where. G is inside, so put G inside of F. So everywhere in F, you used to see an X, now put G. Okay, and then like I said, third time's the charm. If it hadn't clicked yet, it should click on this next one. F of G of X is F composed of G of X. F is x squared plus 3x, x squared plus 3x plus 1. So darn you F, you have a couple x's. So I have to plug in 2 different spots. But G is x squared, so in those 2 spots, I'm going to plug in an x squared. So it used to be x squared plus 3x plus 1, but I'm supposed to plug in G into those spots. So I have x squared plus 3x squared plus 1. And yes, of course, this requires me to remember my rules of exponents. So since I'm raising a power, I do 2 times 2 and get 4. 3x squared plus 1. But again, all this notation meant was everywhere inside F, I saw the letter X, I put what G is instead. Okay, are there any questions about fog? Okay, then let's go back and do Goff. So we did fog, let's handle Goff. So sadly, like I was saying, fog and Goff don't give us the same answers because now everywhere in G I see an X, I'm plugging in F. So it's a little different. So G is 5x minus 6. Well, I'm supposed to plug in F. So it used to be 5x minus 6. Well, X is now negative 3x because that's what f of x is. So sad day, when I multiply that out, I get negative 15x minus 6. And like I said, I'm really sad because these two answers didn't match. You would think your fog and Goff answers should match, and they don't necessarily. Okay, so let's say this again. The outside letter is G, so I'm using G, so that's why I did 5x minus 6. But instead of an x, I plug in what f of x is, which is negative 3x. Are there any questions about number 1? Okay, number 2, we need to do the same thing. So we found fog, we still need to find Goff. So G and f of x. So I need G. G is x squared plus 3x minus 10. During UG, you have 2 different slots, x squared plus 3x minus 10. So in both of those slots that used to be x's, I need to plug in f of x, which is x plus 4. So I'm going to have to do x plus 4 and x plus 4 in both slots. Okay, and then let's get real on this problem. Why is it especially important that I put the x plus 4 in parentheses? So you distribute, he says. Be specific with me. Okay, everyone can have a point because I heard other people say it, but Travis explained it best. And I'll put in layman's term what Travis said. If we didn't have, let's just do the back part. If we didn't have that plus 4, if we didn't have this all in parentheses, you would say it's 3x plus 4. You would not think to do 3x plus 12. So if you didn't use parentheses, you wouldn't think to distribute the 3 times 4 and get 12. And Travis is also right. If you didn't have this in parentheses, you would think it's just 4 squared, which is 16. Really, this is entire binomial squared. Okay, I'm going to write it to the side for those of us who have not clicked, like, it just hadn't clicked yet. It's fine if it hadn't. But surely it has with someone by now. Can someone tell me what 3 things I should write here? If I foiled this out in my head, what would it be? X squared plus what plus 16? What's the middle? For those of us who need to, x squared plus 4x plus 4x plus 16. And so it should be 8x. If you need to write it out, you still can. No one's going to get mad. But oh, wouldn't it be nice if we could start doing some of this in our head and stop having to write this down? Wouldn't that save us some time? Okay, I'm not done because I got to combine my like terms. So I still have x squared, but 8 and 3, I get 11. And Travis said plus 18, and he's correct because 16 and 12 is 28, and then minus 10 would be plus 18. And I just said 18 and I wrote 10. Sad day. But again, our answer for golf, we got x squared plus 11x plus 18. Our answer for fog was completely different. Yeah, they both started off x squared, but their middle and their last terms, they don't match. And it's okay that they don't match. They're not supposed to match unless there's a certain word and it's not there today, so they weren't supposed to. Okay, we have one less golf, and then it's on you. That's what it was when it was fog. But with golf is x squared. Sad day, so I need the entire thing squared. So it's going to be x squared plus 3x plus 1 squared. So G was x squared. I'm plugging F, and everywhere there was an x, I'm plugging in F. So now it's going to be x squared plus 3x plus 1 squared. And what I thought was going to be the easiest problem of the day has now turned into the hardest. Why is that? But that's not the word I want you to use, is it? I don't want to hear multiplied. What word am I looking for, Travis? Yes, whoever said it. Why don't you say it a little happier? Whoever said it, I heard the word I wanted. Say what now? Yeah, I won't distribute. You can have your point, ma'am. X squared's got to go to x squared, so that's x to the 4th. X squared's got to go with 3x, so that's 3x to the 3rd. And you better watch me because I messed this up first period. Plus x squared. So I gave the x squared to everybody over here. I've got to go back and give the 3x to everybody. So 3x times x squared, that's 3x to the 3rd. 3x times 3x, that's 9x squared. 3x times 1, that's plus 3x. Okay, so I distributed the x squared, I distributed the 3x. It's a sad day, I still need to distribute the 1. So 1 times x squared, I get x squared. 1 times 3x, I get plus 3x. 1 times 1, I get plus 1. My gosh, that was a lot of work. My calculator doesn't do x stuff for me. I don't know if yours is fancy enough to do. But no. Okay, I can combine my like terms. I need a little help. No. Okay, he said 6x to the 3rd. 3 and 3 is 6x to the third, so he seems right about that. What did you say for the squared? 1, 9, and 1, so you make 11. 3 and 3, so you make 6x. And then plus 1, that is correct. You can have your point. But again, this is all stuff we should be able to do. The new thing today was figuring out what on God's green earth golf meant and how to do that well. Not how to simplify it, but how to get from this pink to this line. That was the main deal. Okay, if you were concerned and you want to practice this before you take a checkpoint because you realize the checkpoint is going to take you all year because you really didn't understand what was going on today. If you are wanting to practice some things, you can always look at your notes because eventually I'm going to make you do, or if you're wanting a challenge, this would be smart as well, the very back page of your notes, the very last 3 problems, you could ignore the directions, do fog and golf, and go ahead and be on top of your game. Now, here's why Drea doesn't really want to do that. She might want to practice the 4 just because she wants some practice. Why would she want to skip number 5 today? The fraction. She's not really in the mood to deal with it. If she feels like doing it, she can handle it. But we did easy ones today that didn't, well, I say easy. They were complicated, yeah. But we did easy ones today that didn't involve fractions. So if you're not adventurous, maybe you don't want to try the back. I'm just trying to give you some options so we don't spend 3 years on the same checkpoint. Okay, here is your chance. If you didn't finish your checkpoint from yesterday, that would be smart. If you would like to get half the checkpoint done today, that's tomorrow's problem. You sure could. That would make your tomorrow self happier. And then last but not least, because the zeros are going in tomorrow, have you done all 4 parts to all 5 of these problems? Good gravy. Allison, bring me all this stuff in the 3, please.